Good evening all. The last class we had studied about the inventory, the basic concepts of inventory, the utilization of inventory, and why do we use or what are the different models which we use. So now in detail we'll be learning again about those inventory models. So last class we had learned about that inventory model 1, which is the case 1 of manufacturing model. So inventory model case 1. In the case of purchase model, first one, we are having the following assumptions that the demand is constant and the order is replenished instantaneously or immediately. As soon as there is a demand for the order, it is instantly given for order, and the items are consumed at constant rate and the orders are of equal size. So based upon that, we have discussed that the last point, which is shortages are also not allowed, based upon which we had discussed about the problem. So that problem we'll just revise it once again, just to brush up, and then we will start with our new case 2 or the purchase model case 2. So in the case of this purchase model 1, we are finding out the following: EOQ, optimum number of orders, and the minimum total cost of inventory. So now to find out that one, what we are doing, we are taking the values which have been given, which is annual demand, which is 10,000, unit cost of the item, which is 2 rupees, ordering cost, which is CO, which is rupees 36, and the interest rate, which is 0.09. So based upon that, we are finding out that the EOQ or the economic order quantity is coming to be around 2000 units. Just a minute. And based upon the EOQ, we can find out now what is the optimum number of orders which we have obtained, which is nothing but D by Q. So which will give us the unit or the optimum number of orders to be equal to 5. Optimum number to be 5, and the minimum total cost of inventory, which we are again putting on formula, and we are getting that to be rupees 360. So this is an example of purchase model case 1 problem. Next is case 2, where like for case 1, we are having the following assumptions that the demand is in varying rate and the instantaneous replenishment, as like case 1, is occurring over here also. Even the shortages are not allowed here also, and the orders are of equal size over here. Based upon that, utilizing the following formulas or notations, we'll find out the different time periods, that is D1, D2, D3 up till Dn are the demand in different time periods, and the total demand for the time t is given as D1 plus D2 plus D3 up till Dn, where time period or the time is T1 plus T2 plus T3 up till Tn. Similarly, when we are having the ordering cost in time t, then the ordering cost is given as D by Q of C naught, and the carrying cost is given as sum of that quantity by 2 T1 plus quantity by 2 T2 plus up till Tn into Cc, which gives us that the total term to be equals to Q by 2 of Cc into T1 plus T2 up till Tn. And based upon these formulas, we can find out what is the amount of inventory which is required for a particular property or a particular service. So same manner, likewise, when we find out the derivative of the maximum part, then we'll get that the maximum quantities or the optimum quantity is given as the square root of 2 into D into CO by Cc into T, which are having the usual notations as like the previous one. So based upon this formula or based on this formula of quantity, we can find out what are the values of the or total number of inventory things which are required for a quantity can be found out by utilizing this purchase model too. Next is the case 3 or the third case when we started off. Again, we'll be having the same some assumptions to start it off, which states that the replenishment is instantaneous, the back orders are carried out as the fresh stock arrives, and the time period of one cycle is fixed, or we are having one fixed time period for a particular cycle. Based upon that, we'll plot the graph between the same time and the quantity to find out what is the inventory level. As like our first and the second part, or the case 1 and the case 2, this even goes towards the negative axis. And based upon that inventory level, we'll be now finding out for the time at which that cycle is completed, which is being given over here. That T2 by T or T2 by QS is equal to T by Q, and T2 by T equals to QS by Q, where it indicates the number of quantities and T indicates the time for which we need to reorder or order it over a certain period of time, where the ordering cost is given as D by Q into overall cost CO, and the carrying cost is given as the average inventory level for the time T is equal to Q minus QS by 2 of T1 plus 0.2 plus T2 by whole over of T, or which indicates that the final formula which comes to be equals to Q minus QS to the square whole by 2Q. And the annual average carrying cost, or the annual carrying cost, is equal to this average inventory which we have found out into the inventory carrying cost, which is given as Q minus QS by 2Q into CC, or the average inventory level which we have just found out, which is Q minus QS by 2Q, Q minus QS square divided by 2Q into the inventory carrying cost, which is C into C. Similarly, we can have the shortage costs also, that the average inventory during the shortage period will be equals to Q by 2 into T2 by T, which gives us Q square S by 2Q. And the shortage cost is nothing but the average number of units which are short in the inventory into the cost of being short 1 unit in the inventory. And similarly, the shortage cost equals to Q square by 2Q into CS. Hence, the total inventory cost TC is equal to D by Q of C naught plus Q minus QS by 2Q of CC plus Q square by 2Q of CS plus D into P. And based upon this, overall we can find out the total inventory cost which is required, like in case 1 and case 2. Similarly, to find out the maximum value of Q, when we differentiate it, then we'll get that value to be equals to root over of D into CO by CC into root over of CS plus CC by CS, which D indicates the demand, C of the cost, and CC of the inventory cost. And with these usual notations, we can find out what is the optimal value of quantities which can be stored or which can be used as inventory. So here, up till here, we have studied about the purchase models, and based upon that purchase models, in case 1, case 2 and case 3, we have found out how to find out what is the optimal value of quantities which can be stored in inventories. So that's what we have found out in this purchase model. Next part is the manufacturing model. Or during the manufacturing process, if we are having a certain part of inventory, then how to deal with it. Like for example, if a company is manufacturing its component which is required for its main products, then the corresponding model of inventory is called the manufacturing model. Like for example, if we take a bike, then all the accessories which are coming along with the bike is coming under this manufacturing model inventory, where due to the wear and tear of the vehicle as it moves, there are certain replacements which are always required. So when the replacements are required, we need to get these products, or we need to have these products immediately at hand so that they are readily available for the customers. So in order to have that, we need to create that inventory quantities which are required, which will be coming under this manufacturing model. Hence, if a company manufactures its components which are required for its main product other than the corresponding model of inventory, it is called as the manufacturing model. As like here in this case, we'll be having the following assumptions: that the items are produced and consumed simultaneously for a portion of the cycle time, or not for the entire cycle time, but for a portion of the cycle time. And the rate of consumption of items is uniform throughout the year. The cost of the production per unit is same irrespective of the production lot size. Even if we produce more amount of items or less amount of items, the Cost of production per unit remains the same. And even shortages are also not allowed over here. Based upon which, if we want to find out the formulas, then these are the different notations which are utilized in this case 1 of manufacturing models, which are K, R, C, O, C, C, and D, which includes the rate of production is K, rate of consumption is R, ordering cost per order is CO, and the carrying cost per unit per year is CC. Along with which we are having the annual demand of the item, which is D. And utilizing these notations of K, R, CO, CC, and D, we can find out what are the number of quantities which are to be required for inventory during our manufacturing model. Same way, like the previous one, when we draw a graph or when we plot a graph between the inventory model or inventory and the time, or between the rate of production and the rate of consumption, where R represents the rate of consumption and K represents the rate of production. Then we have the time, or then when then we have this final manufacturing model plot or the graph. Just a minute. So anyone is having any doubts up till here? What is inventory cost? Okay, Deepak. Okay, Mr. Deepak. As you have asked that, what is the inventory cost? Like for creating this inventory, what is the amount of cost which is required? That will be coming under the inventory cost. Like for example, just now, as I was saying, the accessories of the vehicles which we are creating. Okay, so for that one also, we'll be creating that in a lot. Okay, as a production unit, we will be generating a lot amount of those accessories which are to be kept and which are to be transported to different areas or different places whenever and wherever it is required. So according to that, the cost which is involved in utilizing that, or the cost which is involved in making these accessories to be stored or transported to a particular area, comes under the cost of these inventory costs. Okay, I hope now it is being understood to you. So coming back to our topic, the manufacturing model of case 1 will be having the rate of production which is K and the rate of consumption which is R. And as per the difference between this production and the rate of consumption, we will be having the different manufacturing models. Hence, in the usual manner, we will be finding out the ordering cost by utilizing the demand line quantity into the cost, which will give us the ordering cost, the carrying cost, which is the average inventory during this time T1, is this K minus R by 2 into T1, which when solved or which when further equated, it has been given as the carrying cost to be equals to Q by 2 of 1 minus R by K into CC. Then the total inventory cost is equal to this sum total of all these costs, which is D by Q of CO plus Q by 2 of 1 minus R by K into CC plus the optimum value of the Q, or the optimum value of Q which is obtained, or the quantity which is obtained, is given as the square root of 2 into the demand into cost divided by 1 minus R into K, which is products which are consumed and products which are produced, into CC, or the cost, carrying cost which is occurring, that is given by CC. And based upon this, we can find out what is the total manufacturing cost or the total inventory cost for this manufacturing model of case 1. Hence, when we find out these values, or when we find out what is this manufacturing model, the characteristics of these manufacturing models or the formulas are being given as the EOQ is equals to root over of 2 into D CO divided by 1 minus R by K into CC. Total number of units n equals to D by Q. The time required for this is Q by D. The time required for a particular period T1 is equal to Q by K minus R. And for another particular period of time is Q by R. And finally, the total cost for this manufacturing model is given as D by Q star of CO plus Q by T of 1 minus R by K into Cc. As per this, if we solve a problem, then you'll be much clear. So based upon that, the example problem of this one is that an ABC company produces a cable at the rate of 5000 meters per hour. Every hour, it is generating a cable which is of 5000 meters for 1 hour. This cable is used at the rate of 2500 meters per hour. For utilization of the production process, or once the production is being done, it is being utilized in the industrial area at the rate of 2500 meters per hour. And the cost of this cable is rupees 5 per meter. So the inventory carrying cost is 25% and the setup cost is rupees 4050 per setup, or 4050 for once if we do the setup. So now we need to find out what is the optimal number of cycles which are required in a year for the manufacturing of this cable. So utilizing this model, in this problem we'll find out how many times or what is the optimal number of cycles for manufacturing it or manufacturing this cable in a particular year. To find out that value, we'll be utilizing this formula or this case. Since we know that the production rate, which is K, is 5000 meters per hour and the consumption rate is 2500 meters per hour. And for each unit, the inventory cost is rupees 5 per meter and the inventory cost is 25% of that one. Carrying cost is 25%, which is given in the question, and the setup cost is 4050. Based upon that, we can now find out what is the annual demand. That is, the consumption rate is 2500 for 8 hours in a shift if it is working into 365 days in a year, which will give us the annual demand for the cable which is being produced in 1 year. And based upon that, the economic order quantity is, when we apply these 2 into 2500 into 8 into 365 into 4050 divided by 1 minus 2500 by 1000 into this carrying cost Cc, then we'll be getting that value to be 30 lakhs, 3 lakhs 7585, or the total quantity or the optimal quantity is given as this total demand divided by the total quantity or EOQ, which is 2500 into 8 into 365 divided by 3,07,855, or which includes 24. So from this inventory model, we finally conclude that in a year, if 24 times, if we put the setup, then we'll be able to manage the inventory model for the manufacturing model in a proper way. Next, coming to our next case, which is case 2, where we are having the assumption as items are produced and consumed in a simultaneously for a portion of the cycle time. The rate of consumption of the items is uniform throughout the year. The cost of the production per unit is same irrespective of the production's lot size. Whatever may be the lot or how many number of products we utilize, the cost of production will remain the same per unit, and the stock out is permitted. And finally, these stock out units will be satisfied from the units which will be produced at a later date with a penalty, which is back order. Like in the previous cases, once the stock is completed, immediately we need to replenish that one. Here in this case, when the stock out units are satisfied from the units which will be produced at a later date with a penalty back order. That's what we are assuming in the case of this second part, which is manufacturing model case 2. In the same manner, when we plot a graph between the production and the consumption, then we'll find out that along this axis, we'll be able to find out what is the number of inventories which are required over a particular region. Like we see over here, in this case, we are having the production or the number of items which are produced and the number of items which are required to be negative. and here it is positive, and based upon that production and this items which are being required to be consumed, as per that we are ordering or we are receiving the inventory which is to be done. Hence, over here the total inventory cost is given as R by Q of CO plus Q1 by 2 into T1 plus T2 by T into CC, or the cost which is required, plus second quantity Q2 by 2 T3 plus T4 by T into CS, and the overall quantity Q star or the EOQ will be given as 2 into COR by CC root over into root over of CS plus CC by CS into root over of K by K minus R, where these all are having the individual values or individual notations as we have discussed in the previous slide. So the formulas which are required over here are the EOQ is equal to the 2 COR by CC into CS plus CC by CS into root over of K by K minus R. Q1 star is equal to Q star of CS by CS plus CC into K minus R by K, and Q2 is equal to K minus R by K into Q star minus Q1. The time period for which it is occurring is Q star by R. For each individual T1, T2, T3 and T4 we can find out respectively as Q1 star by K minus R, Q1 star by R, Q2 by R and Q2 by K minus R. And finally, the total cost TC is given as R by Q star into CO plus Q1 star by 2 into T1 plus T2 by TCC plus Q2 by 2, T3 plus T4 by T into CS. And up till now, or here we have discussed up till the manufacturing models which will be utilized in each of the inventory systems. So just a minute. Now we'll be studying about the control of inventory systems, or how the inventory system is needed for control. Like up to here we have studied about the manufacturing models and the purchase models, or the models which are utilized to optimally utilize the inventory, or to stock out all the points, or to stock out all the products which are being generated. How to control that can be understood by the three cases of inventory models of the purchase model and the manufacturing model. Now, even though if we control that one, if there are certain chances that this inventory system, due to some abnormal reason, they cannot be controlled due to some uncontrollable reason. So during that conditions, we'll be utilizing some amount of control systems over this inventory, which is nothing but the Q system and the P system, which requires certain amount of fixed order, quantity system and fixed periodic review systems. What is that? We'll just learn. Before that, if you are having any doubts, please ask. Okay, Deepak. You have stated that you have not understood. Okay, read it once again. Okay, fine. What is the inventory cost? Okay. So during this condition of inventory, what do we generally do whenever we need to do certain things? Like for example, if we want to, if we go to a bakery shop for ordering a cake. Okay. So for ordering a cake, we cannot assume what is the number of cakes which will be ordered per day. So there will be certain amount of minimum level of quantities which are to be ordered, like wheat flour or the flour which is utilized and the flavor which is utilized for the cake. Everything will be stored for a certain period of time. That stored amount of system or stored amount of stock which is being present, that is generally called as our inventory. So before we produce our product of cake and sell it, there is certain amount of cost which is involved to bring that one and to transport that one. Okay, that cost which is involved in bringing this and storing it is generally called as our inventory costs. Okay, I hope now you have understood that one. Okay, so coming back to to our topic of inventory system, of Q system and P system. In the case of this Q system, we generally say that it is fixed order quantity system, where the order is completely fixed, and based upon the orders, we will be again finding out what is the reorder level which is required, which is when it reaches the point below this start, or below this point. Whenever it reaches, then the demand will be for reordering another products, or for achieving that products, or for bringing the products. It's time for reordering those products. That's why that is called as reorder level. And the average demand during this lead time is called as the demand during this lead time, or DLT. Below which, when we come, then it is generally called as our reserve stock, and which is responsible for the average demand during delivery delays in the reserve stock. Or whenever there is certain emergency, then from this reserve stock, we will be taking it and giving it. And finally, the safety stock will be present, which is variation in demand during this time is known as the safety stock. And always this reorder level, or ROL, is always given as the demand during the lead time plus reserve stock plus safety stock, which is utilized. Hence, we say that the following notations are being utilized for a Q system of inventory control model, where demand during the lead time, DLT, is given as demand per unit time into the lead time. Average demand during the delivery delays is reserve stock equals to annual demand into maximum delay in weeks divided by the number of weeks per year into the probability of maximum delay. Similarly, the safety stock is given as K into sigma, where K is the service constant and sigma is the standard deviation in demand during the lead time. And based upon the standard deviation per week and root over of lead time, we can find out what are the values of this safety stock, or SS. Utilizing which, finally, the reorder level, ROL, can be found out, which is equals to demand of the lead time plus RS plus SS. Coming to the next one, which is P type of system, or fixed periodic review system. In the same manner over here, we can find out what are the different requirements of inventory, like the minimum and the maximum inventory level, or MIL, which is the maximum inventory level, which is the number of units to be stored at a maximum rate, can be given by MIL, or maximum inventory level. Again, the demand during the lead time, or during the normal production and the operating process, what is the demand which is present, by the lowermost reason, or the reserve stock, which indicates when there is acute need for the product or the raw material, and finally the safety stock during this lead time and review period. This review period, or RP, is given as the economic order quantity divided by the demand which is present, and the maximum inventory level, or the MIL, which is present, that is equals to D into LT plus RS plus SS, safety stock plus reserve stock. So, when we find out an example for this P system and Q system, then we will be having this example, that is, an annual demand, or the annual demand of a product is 48,000 units. The average lead time is 4 weeks. The standard deviation, or the sigma, during the average lead time is 75 units per week. The cost of ordering is rupees 400 per order. The cost of purchase of the product per unit is rupees 10. The cost of carrying per unit per year is 15% of the purchase price. And the maximum delay in the lead time is 2 weeks. And the probability of this delay is 0.25. Now, taking the value of K, or the constant, to be equals to 1.64. With Q system, we will find out the reorder level, and with P system, we find out the MIL, or maximum inventory level. So, as usual, when we take these notations of annual demand D, which is 48,000, lead time, which is 4 weeks, standard deviation, which is 75 units per week, ordering cost, which is 400 per order, unit cost of the item, which is rupees 10, and the carrying cost, which is 1.5 per unit per year. The maximum delay is 2 weeks and the probability of delay is 0.25 as given in the question, and K is 1.64. Next, directly by utilizing the formulas, we will find out the lead time or demand during this lead time, which is demand per week into lead times in week, which is for each week we are having 48,000 by 52 into 4, which will give us 3692 units or 3692 units. Okay, anyone, if you're having any doubts up to here again, you can just contact or you can just again chat. I hope Deepak you have understood what was your doubt. I have cleared your doubt. Please give a thumbs up or a yes sign, yes symbol over here. Next, when we are having the safety stock or for finding out the safety stock, we'll find out K into sigma, which is K into LT to the power S into D, which is 1.64 into root over of 4 into 75, which is 246 units. And the reserve stock during this period is demand per week into maximum delay into probability of the delay, which is 48,000 by 52 into 2 into 0.25, which is giving us 462 units. And finally, the reorder level is demand of LT plus LT stock into demand during this delivered delay, which is nothing but the sum of all this 3692 plus 246 plus 462, which is giving us 4,400 units. Next, to find out the MIL in the P system, we'll be utilizing 2 into D into CO by CC, which is given as 2 into the demand 48,000 into 400 by 1, which is coming around 5,060 units. And the review period is the EOQ or 5,060 divided by the demand, which is 48,000, which is 5.4 weeks or around 6 weeks. Or when we round it off, we say that the review period is 6 weeks. And the demand during this lead time and review period is 48,000 by 52 for each week into 4 plus 6, which is in weeks, which gives us 9231 units. When we find out the safety stock, it is K into sigma, which is giving us 389 units. Hence, the reserve stock during this delivery is demand per week into maximum delay into probability of delay, which is 48,000 by 52 into 2 into 0.25, which is 462 units. Hence, finally, the maximum inventory level or MIL is given as the demand plus safety stock plus the reserve stock, which is 10,082 units. So, maximum inventory which we can do over here is 10,082 units. The other type, so up till here we have learned about the inventory models and the control in the inventory models by the P and the Q system. Now we are learning about the other types of the inventory models which are present. The next one is the very important one, which is JIT or just-in-time production. So in this just-in-time, it is an inventory management system which aims at gaining or taking the raw materials only when it is required without investing in storing it. Like the previous models of inventory models, we found out what is the optimal level of inventory which is required to store whenever there is a production. But here in this just in time, we generally deal with the items which are to be used at the time whenever it is being started. There is no need of any storage is what is the concept of this just in time production. By which it means that as soon as there is a requirement, there will be the products which will be brought out or the raw material which will be procured, and it will be immediately utilized for the production process rather than bringing them and storing them and keeping them as different stocks. So the main advantages of utilizing this JIT or just in time is that It reduces the cost on raw materials. Okay, Alan. Yeah, few questions do come from for gate from this one, but this is directly from the production planning control course. This is for the course production planning control. Okay, generally from the for the undergrad students, whatever syllabus is present, that's what we are discussing over here. Of course, some of these questions are coming in gate, which are present in that, but directly for gate, we are not discussing over here. We are discussing the general syllabus, which are being utilized for the Mumbai University students or the other university students within the course of production planning and control. Okay, Ellen, I hope I have answered you. So, what are the advantages of this just-in-time production? Just-in-time production reduces the cost on storing raw materials. So, whatever cost which we utilize in storing this raw materials is reduced now because we are not storing them but immediately utilizing it whenever and wherever it is required. Even there is a less investment in this raw materials since we are not procuring more amount of raw materials or we are procuring the raw materials only when it is required. Similarly, the manufacturing process speed is being utilized immediately as the products are arrived. They are immediately utilized. So the manufacturing process is fastened a bit whenever we are utilizing this process of management system. It also eliminates the lead time because we are not storing it. So the lead time is completely being eliminated, and it helps in shorter production runs. And finally, the biggest advantage is it eliminates waste in terms of time, inventory or transportation. Any kind of waste, either in terms of time or storage or transportation, is completely being avoided in this just-in-time production. But the disadvantage is that it leads to the potential supply chain destruction. That is, okay, fine, well and fine, whenever we require that one, if it is available and in time, then it is very good. But at the time of need, if the raw materials are not present, then the entire process remains in a lag position due to this unavailability of raw materials. So manufacturers will have no margin to make errors. Even a small error will cause a large amount of production wastage and even production loss also, and time, which is the most important factor which will be lost if there are certain amount of errors. And the other disadvantage is it will be unable to meet any unexpected order from the customer, and there will be no time for renegotiation with the customer. Since it is immediately being produced, so there won't be any time for renegotiation also. So certain EOQ model with price breaks is another example which we can deal with for this inventory model. Like ABC is a manufacturing company which is requiring special involute gear at the rate of 300 per year, and each gear of it costs around rupees 36. The cost for procuring it and the inventory cost or inventory carrying cost are estimated at rupees 30 and 20% for the carrying cost. Now, if the supplier offers a discount of rupees 2 per gear or an order of rupees 200 or above, will it be advisable to purchase higher quantities? Or in this problem, we will be able to identify how much amount of quantity if we procure, then will be at benefit. Since the annual demand is rupees 300 and the unit cost is rupees 36 and the procurement cost is rupees 30 and the inventory cost is 20 percentage, which is 0.2. So price per unit is 36 and 34. So the optimum quantity based on the prices 34, which is Q2, Q1 and Q2, and based upon that Q1 and Q2 we are having 34 to be our optimum price. And now utilizing that quantity by finding out 2 into TCO by CUI, we can find out what is the optimum order quantity which is required. Hence it states that 51 quantities will be the optimum order quantity which is required. And since it is not equals to 200 or more than 200, so again we'll go back to the first one and we'll find out Q1, which states to be the same formula and which gives us that 50 units. So the total cost for the quantity to be purchased will be for 50 and 200 units. for the order quantity of 50 units, when the annual purchase is 300 into 36 rupees and 300 into 34 rupees, then we are having the total cost to be 10,800 and 10,200 for a part. The annual procurement is 300 by 50 into 30, which is rupees 180, whereas if it is order quantity of 200, then it will be for rupees 45. Hence, the annual cost or the inventory carrying cost which is present is rupees 180 for 50 units and rupees 680 for 200 units. Whereas the total annual cost is 11,160 and 10,925. Although the inventory cost for 50 units is less, but the optimal order quantity is 200 units, where we'll be able to save around 1,040 rupees less when it is compared with that of 200 units and 50 units, which you can see over here. That for 50 units will be costing around 11,160, whereas for 200 units will be costing around 10,920. Hence, by ordering 200 quantities or 300 units, it is advisable for optimal order quantity. Similarly, for price breaks, we are having the next example where it states that a company is requiring 50,000 units per year, which costs around rupees 10 per unit. The ordering cost is estimated to be rupees 100 per order. The carrying cost are 15% per annum of this average inventory, which is 0.15. Again, here we are given a 2% discount on the price of the original value of the company, which purchases 10,000 units or more, but less than 20,000 lot sizes. So, a further discount of 1% in price of the original value is available on the order for 20,000 or more units. Now, utilizing this, we need to find out what is the economical lot size and minimum total cost. Whether purchasing 2,000 lot size or 1% discount in the original value will give us a better minimal total cost. Accordingly, we'll write down the annual demand is 50,000, the unit cost of item is 10, the ordering cost is 100, and the carrying costs are 15%, which we have already known, that is 0.1. The price per unit we are now writing down that as 10, 9.8 and 9.7 based upon the 2% discount and additional 1% discount as given in the question. The 2% discount and the 1% original value discount, we can get that values to be equals to price per unit as 10, 9.8 and 9.7. Hence the minimum price is 9.7, based upon which the quantity Q3 is given as 50,000 into 100 divided by 9.7, which is the unit price, into the cost, which is 0.5, inventory carrying cost, which is 0.15 or 15%, which gives us that the optimum order quantity when we order at 9.7 per unit is rupees 2,622. Since it is less than 20,000, so we again go to the step 2 where we find out the value for 9.8 rupees. For 9.8 rupees, the Q2 is given as in the same manner 2 into 50,000 into 100 divided by 9.8 into 0.15, which gives us 2,609. Since this is again less than 10,000, so we again go to step 3 and we find out for 10 rupees. So for 10 rupees, we get that units to be 2,582, which is to be stopped. The total quantities for this 10 rupees, 9.8 rupees and 9.7 rupees is what we are finding out in these different tables, using which we say that the annual purchase cost for 10 rupees is 5 lakhs, 4 lakh 90,000 for 9.8 rupees and 4 lakh 85,000 for 9.7 rupees, for which the procurement cost is 1936.50 for order quantity of 2,582. For an order quantity of 10,000, we are having it as rupees 500. For an order quantity of 20,000, we are having it as rupees 250. When this annual inventory cost includes, it gives us rupees 1936.50 rupees 7,500 and rupees 15,000, where the annual total cost is 5,03,873 4,98,000 and 5,250,000. Hence, the EOQ is given for minimum order quantity of 10,000 and the minimum total cost is 49,000, 4,98,000. This is how we find out how much order quantity is to be given for different models at different prices based upon different discounts and other prices. So, in this case, we have found out that the EOQ is 10,000 and the minimum total cost is 4,98,000. So based upon these inventory models, we have covered up till here what are the inventory models which we utilized and the discount models which can be utilized to calculate what will be the maximum or better or optimal order quantity which is required. Up till here, if you are having any doubt, or else we'll continue with the next cycles, that is ABC analysis. So in the case of this ABC analysis of inventories, generally what they do, they'll be classifying the products into three different categories. And based upon that, the procurement of the goods or the products or the services which are required, that will be divided. So in the case of this ABC analysis, we divide the inventories into three grouping in terms of percentage of number of items and percentage of total values, like A, B, and C, where high usage and valued items are grouped in A, low usage valued with trivial items are grouped in C, and the remaining middle level items are considered as B items. So, as per the analysis of usage or high valued items, we will be classifying them into group A, group B, and group C. And according to that classification, we will be dividing them as A, B, and C analysis. This inventory control is exercised on the principle of management by exception. That is, rigorous control are exercised on particular items and routine use controls for C items and moderate control on B items so that the valued items are not being lost at any ease or any wish and will, they doesn't get lost. So that is why as per that rigorous control will be there on item A, loose control will be there on item C and moderate control on B items. So based upon that, as per that, the percentage of item approximately high value will be 10%, medium value will be 20% and low value will be 70%. Similarly, the percentage of value which is present, that will be around 70%, 20% and 10%. So how to classify them for A items? In the case of A items, they will be high valued items, hence they should be ordered more, but in small quantities, right? Immediately when they are in required, they are in hand and immediately they are being utilized, so that they reduce the capital which is locked up at any time. The future requirement must be planned in advance so that the required quantities arrive a little before they are required for consumption. Since the quantities are less, so we need to plan and order them in advance so that it is ready whenever it is required for consumption. Similarly, the purchase and stock control of A items are kept into the top executives in purchasing department. Or complete control of A items is properly being followed by the management level or top executives who are present. Hence, for the certain policies which are utilized for controlling these A items are maximum effort should be made to expedite the delivery. The safety stock should be as less as possible within 15 days or less. All the items are subjected to tight control regarding their issue, balance, storing method, etc. The ordering quantities or reorder point and minimum stock level should be revised completely more frequently so that rigorous control and proper estimation of all the values of A items are present. Similarly, when we come to this middle level of B items, the policies for B items in general are in between those of A and C. That is, these items are placed less frequently or orders are placed less frequently. The safety stock should be medium, 3 months or less for this safety stock of B. And they are always subjected to moderate control. Finally, C items are low value items, therefore the safety stock of the items should be liberal. They are required for 3 months or more. The annual or 6 months order should be placed to reduce paperwork and ordering cost and to get the advantage of quantity discount for large orders. Hence, in case of these items, only routine check is required, not continuous and rigorous checks, but routine check is generally necessary. Hence, for ABC analysis, these are the following steps which you follow. First, we calculate the annual usage in units for each items. Next, based upon the calculated annual usage of each items in terms of rupees, we find out the annual usage. That is, annual usage into unit cost. And then we rank the items along the highest annual usage in rupees to the lowest annual usage in rupees. And finally, based upon the total value which we have obtained, we find out the percentage of high, medium and valued items in terms of total value of items. Once we get these items, then a graph is plotted between the percentage of items and percentage of value or total value of items along the abscissa and the ordinate, and we get the values. Like in this case, just see, based upon the total percentage of value and the percentage of items which are present, as per the plot, we have divided them into A, in between 20 to 30, 30 to 40 is B, other parts is C. For example, there is an engine manufacturing company which stocks the items as shown in table in this store. And based upon these categories, we need to identify them into A, B and C categories. Like the code C1 belongs to connecting rod, C2 belongs to crankcase, C3 belongs to cylinder, C4 belongs to cylinder head, C5 to crankshaft, C6 cam, C7 nozzle, C8 valve, C9 fuel injection pump, and C10 exhaust pipe. As per these, based upon the prices and the annual demand for each of them, 500, 600, 4000 respectively, up till 500 to 600, individually we will find out the price unit and the total annual consumption. Like for example, the connecting rod is 500 rupees per unit and the annual demand is 600. So when we multiply that 600 with 500, we will be getting that to be around 3 lakhs. Similarly, 24 lakhs, 12 lakhs, 18 lakhs, 24 lakhs, 66 lakhs, 3 lakhs, 12 lakhs, 9 lakhs and 3 lakhs are the individual components which are being obtained, such as connecting rod, crankcase, cylinder, cylinder head, crankshaft, cam, nozzle, valve set, fuel injection pump and exhaust pump. Accordingly, now as I have got the annual consumption, and based upon these annual consumption, cumulative consumption is being obtained, which is nothing but the addition of all the values. Crankcase highest 24 lakhs plus crankshaft, which is highest 24 lakhs, 48 lakhs, 48 plus 18 66, 66 plus 12 78. In that manner, when we do it, then we'll find out that it is coming to be around 1 crore 14 lakhs. Is the cumulative consumption of rupees per year for purchase or consumption of all these products in these respective units which were given. And the total value is the overall total value divided by this cumulative usage, which gives us 68.5%. Hence, based upon that, we are classifying them as A, B and C. Okay, so let's stop it over here. We have the other topics of WED analysis, VED analysis and the other analysis in the next class. Once we do with that, then our topic for today or the inventory models will be completed. Thank you.